So looking at number 2, the rate at which water flows into a pond in gallons per hour is given by a differentiable function r of time t. The table below shows the rate, r, as measured every 4 hours for a 24-hour period. Part A, estimate from 0 to 24 r of t dt. So that's the area under r from 0 to 24. If you're worried about like what this represents, well, first, it doesn't really matter right now because it tells you what to do. So like what the answer means doesn't really matter yet because it says do this, so we'll do that. Later, we can ask the question that leads to that, so you have to understand more of the problem. But for this problem, if you didn't understand it, it'd be okay because you're still just going to follow what it says to do. But r of t is in gallons per hour. dt is the time, so that's in hours. So if you multiply those, you get gallons. And so trying to get a feel for this problem, the rate it flows in is gallons per hour. And so if we multiply that by hours, we'll have how much total gallons have flowed into the pond. Again, you don't really need to know that for this problem because it just flat out tells us what to do. So the intro stuff is usually important, but this one you could work without ever even reading it. All right, so estimate that using a left Riemann sum with 6 subdivisions. So I count, there are 7 data points, but that makes sense because if we think about the rectangles that would be made here, I don't know what they look like. It makes 6 rectangles.
So the widths of the rectangles don't have to be equal.
And that's the tricky part of this one. The widths aren't the same. It's kind of annoying. The first one, the widths were all 20. Here, they're changing. So we got to slow it down a little bit and be careful. So this first, go ahead.
Wait, so then, but like when you do the the number minus the number over like the number of divisions, you get like a width, right?
Okay, the question was, usually we get like the total width 24 divided by 6 regions, so that should be 6, but they're not equally spaced. So we can't, the width is prescribed. We don't have to figure the width out. It's another way to say that.
So it's more like they gave us crappy rectangles and we
Yes.
can't do anything about it?
They gave you crappy rectangles and you can't do anything about it. That's exactly right.
Okay.
Yep. That's exactly right. Principal just walked by, didn't hear me say crappy rectangles. But that's exactly what's happened. They've given you unequally spaced rectangles. Would be the more formal way to say that, but you're right. So this first rectangle goes from 0 to 5. The left height is 6.2, the right height is 7.1. So if we want a left Riemann sum, how wide is the rectangle? Which rectangle? How wide is that rectangle? 5. And which height should we use? The 6.2. So there's our first rectangle. The next rectangle goes from 5 to 9. So how wide is that rectangle? 4. Hesitant to answer. And what height should we use? 7.1. Then the next rectangle goes from 9 to 11. So that width is 2. And we'll use the height of the left, 9.3. And maybe it's overkill to put the post-it notes on there and cover it up, but that's what your brain is doing. If you don't have the post-it notes, you have to look, like rectangle by rectangle. So, there's no shame in using that. It really helps you focus. Okay, from 11 to 15, well, that's 4 wide. And if I want the left Riemann sum, then I'm going to use 9.1. And I'm going to go 15 to 21. That's 6 wide. The left-hand height is 5.7. And then 21 to 24 is 3 wide, and the left-hand side is 2.1. And that's my answer. I don't have to, that's a safe stop. But it's hard to come up with all those numbers without using the post-it notes because there's just so much stuff going on. Natalie?
For B, the widths would be the same, right?
Correct.
Okay.
The widths would be the same. That's right.
Then you're just using the right one.
That's a good observation. The widths would be exactly the same.
Okay, just making sure.
Mm-hmm. But then you would use the right-hand heights. And one that's a little bit maybe confusing is that negative 1.2. What does that mean? The fact that that one's negative. What's that mean in terms of the problem? What's happening to the pond? It's decreasing. The water is flowing out of the pond. So R is the rate at which it flows into, but if R is negative, it's flowing out of. So we add water for the first 20-something hours, and then somewhere in there it switches and starts draining out. Part C, trapezoidal sum with 6 subdivisions. Okay, well I guess the good news is with 6 subdivisions, it's the same width. So the same width again. I'm going to try to space them out because I know the height. So there's my 6 widths. And what will I use for the, how do I find the area of a trapezoid?
Height 1 minus height 2, height 2 minus
Careful, you said height 1 minus height 2?
height 2 minus height 1.
Nope.
What? Yes.
Right, you want the average height.
Yes.
So height 1 plus height 2 over 2.
Okay. That's fine. I knew that.
Setting it up piece by piece here. So the first 2 heights are 6.2 and 7.1, and 7.1 and 9.3, 9.3 and 9.1, and so on. And that's a safe stop. Like, I don't want to plug all that in. It's way too many numbers to be punching in a calculator. Good on number 2. 3, A or B? Those are sort of back to, I think, easier ones, or what we think of are easier ones.
Could you go over A, but the lower part?
Okay. So the lower sum on A. 9 minus x squared from 0 to 3. Again, the picture isn't absolutely necessary, although it might be to figure out which one's upper and lower. And 3. You know, one thing I don't like about a lot of calculus books, and this worksheet included, especially given number 2 where there weren't, the rectangles were crappy, in your words. We generally assume that we like equal intervals, But a lot of times the book doesn't say that. And so, if you wanted to be crazy, you could set this up with 3 unequal intervals. I don't know why you would do that, but you could, because it didn't exactly specify to use equal subintervals. Now, having said that, I'm going to use equal subintervals because that's what most people would do. So each interval is going to be width 1. And for the lower sum, do I want the right hand or the left hand? Which one would be the lower sum? The right. Again, if you need the Post-it note to look at one rectangle, okay, there's one rectangle. If I want the lower sum, it needs to be from the right. The lower sum needs to be from the right. The lower sum of that last rectangle is going to be 0. So lower sum equals width times f of 1 plus width times f of 2 plus width times f of 3. F of 1 is 8. F of 2, 9 minus 4 is 5. And f of 3 is 0. So you could leave off that last term and still be accurate. I'd probably leave it on there because now I think it's clear I'm adding 3 rectangles. So the lower sum is 13. So I don't know what the area is, but it's more than 13. And if you did the upper sum, you'd have the top sort of an upper limit on what the area would be. Did that answer your question?
Yeah. I don't know, I just got confused